Okay, second and higher derivatives. Page 381 reading. It asks, how do you find the second derivative of a function? So basically, what you do is you take the derivative with respect to x 2 times. And then what you end up getting is f dash x. So you have 2 dashes. Okay? Write down 3 different notations to represent the second derivative. Okay, one of the notations I just put, which is f dash x. Another notation would be, instead of writing dy dx, you write d squared y dx squared. The other notation would be y dash dash. Okay? Alright, then write down 2 different notations to represent the nth derivative. Okay, so here we got these 2 examples. One is f to the n, so instead of having a bunch of dashes here, we're just going to put an n in parentheses, which means n dashes. And here we have the dn, instead of d squared, we have d to the nth y dx to the n. Okay? Alright. Okay, there's examples 14 and 15 in the book. And then we can find the second derivative given that, and it gives us these functions. It wants us to take the derivative twice. Okay, so pretty soon we're going to find out why it's useful to take the derivative twice. We know why taking the derivative once is useful. Taking the derivative once is the rate of change of the function, or you can think of it as the gradient or slope of the function, and that's pretty useful a lot of times. Okay, now later I'll explain why double derivative or the second derivative is useful. Okay, let's take the first derivative of this. So f dashed of x is equal to 3x. The derivative of 3x squared is 6x. The derivative of negative 6x is negative 6, and the derivative of 2 is simply 0, right? Now what if we took the second derivative? All we're going to do is take the derivative again of the resulting function. So now we're just going to have the derivative of 6x is 6, the derivative of negative 6 is 0. So now we just have f dash dash x equals 6. And that's it. That's the second derivative of the function. It's just a line, right? A horizontal line. Let's do this function. The first derivative is going to be 6x squared of 2x cubed, right? And the derivative of negative 3x squared is negative 6x. Oops. And then the derivative of negative x is negative 1. And then the second derivative is going to be 12x minus 6. Okay. And then let's do this last one. This one's a little bit more difficult. The derivative of this would be, using the power rule, 3 times 1 minus 2x, and then using the chain rule, and then to the squared, and then we're going to multiply times the derivative of what's inside, which is going to be negative 2. So if we simplify that, it'll be negative 6, 1 minus 2x squared. And since we're going to take the derivative, again, it's more important than normal to simplify. So now we're going to take the second derivative, and we're going to have the power rule again. This time we're going to, when we put out the 2 out front, we're going to have negative 12 because we multiply it times the negative 6. And then we reduce the power of 2 to 1, and then we're going to multiply times the gradient, or the derivative of what's inside, which is going to be negative 2, because the derivative of negative 2x is negative 2. Now we simplify. We're going to put 24 times 1 minus 2x to the first power, which is no power at all, right? If you want to, you can multiply this out. It would be 24 minus 48x, for example. Okay? So we've been taking the second derivatives here. Now they say find d squared y dx squared given that. And again, same thing. Remember, y is the same thing as f of x. And d squared y dx squared is the same thing as f dash dash. So we're just doing the same thing. They just asked it in different ways. So the derivative, the first derivative of y dash, is equal to 1 minus 3x squared, right? Because the derivative of x is 1, the derivative of x cubed is 3x squared. The second derivative is equal to, the derivative of 1 becomes 0. The derivative of negative 3x squared is equal to negative 6x to the first. Okay, and that's it. Okay, C. Now we have, when we take the derivative of this, the derivative of 2 is 0, so we don't write down anything. The derivative of negative 3 divided by square root of x. Let's rewrite that. Instead of writing negative 3 square root of x, let's write negative 3x to the negative 1/2. It makes it easier to take the power function by rewriting the exponent. So this would be, let's see, negative 3 times negative 1/2 would be negative 1.5 x to the, and we're going to reduce that power. Instead of negative 1/2, we're going to put negative 3/2. We're going to reduce it by 1, right? Because that's what the power rule says. And and that doesn't really simplify. That's pretty much it, right? And then what about y dash dash? Y dash dash, we would take the negative 3/2 up top and we would bring it down. So actually we're going to have, 1.5 is 3/2, so we could put 3/2 twice, right? And the one we bring down is a negative, so we can make that positive. And then we're going to reduce the power of negative 3/2 even further by 1. It's going to be negative 5/2. Okay? And so if we're going to simplify that, we'll put 9/4 x to the negative 5/2. Okay. E. Let's take the derivative of this function. So we're going to have 3 times x squared minus 3x squared. And then we multiply times the derivative of what's inside. 2x minus 3. Okay? And then that is the first derivative. And the second derivative would be, we're going to have to use the product rule now, because we have two kind of complicated things multiplied times each other, right? The other way to do it is you could expand this, but it would be it would be pretty huge. Okay, so let's do the product rule. And so basically we'll use this as one of the functions, and this is the other function. I'm going to erase this for a second, okay? And then enlarge this. Okay, so we're going to have u equals x squared minus 3x quantity squared. And v is equal to 2x minus 3, right? So u dashed is going to be equal to 2 times x squared minus 3x times, and then we have to multiply it times the derivative because of the chain rule. Okay. And then v dashed would be equal to 2, right? And then when we take the second derivative, we're going to multiply 3 times everything, because this 3 here, we can't leave it out. Okay? So 3 times, and in the middle we're going to put u, which is x squared minus 3x squared, times v dashed, which is 2. And then we add to it u dashed, which is 2 times x squared minus 3x times 2x minus 3. Times v, which is 2x minus 3. And so look at, there's two 2x minus 3's here, so we could combine those two like that. Okay. Alright, and I think I wrote something wrong here, because look at that. why is that squared? Let's look at this again. Oh, I miscopied this. I should have had that exactly the way it is. Because it's u, right? So it should be minus 3x, and this should be squared, like that. Okay? Looks like we can factor out a 2, those two 2's, so we can have 6 factored out instead of 3. And then we'll have x squared minus 3x squared plus x squared minus 3x times 2x minus 3 squared. Okay? I don't know if that simplifies, but that's just algebra. Okay, 3a. Given that the function is equal to this, find the first derivative and plug in x equals 2. So let's define the first derivative. The first derivative of the function is equal to 3x squared 3x squared minus 2. Let's find the second derivative because later we're going to use that. The second derivative is equal to 6x. And what is the third derivative? Because later we're going to use that. Actually, I shouldn't write that. I should write f to the 3x is equal to 6. Okay? And I think that's as far as we go. So let's plug in x equals 2. If we plug in x equals 2, it'll be 3 times 4, which is 12, minus 2, which is 10. Okay? What if we plug in x equals 2 for this one? Notice that we are always plugging in x equals 2 after we take the derivative. We do not plug in x equals 2 before we take the derivative because then, well, you'll see what happens. Not a good idea. Okay, and then, last of all, we're going to plug in x equals 2 for this one. And actually, you notice that there's no x left in this one. So it doesn't matter what you put in. It's always 6, okay? Because the gradient is always constant, which means it's a line. Okay? All right, number 4. Suppose that y equals a times e to the kx, where a and k are constant. Show that the derivative of a e to the kx is equal to ky. Is that true? Let's see. Let's take the derivative of this. So derivative of y is equal to a times e to the kx because the derivative of exponential function is itself. Then you multiply times k because k is the derivative of kx, and we have to use a chain rule and take the derivative of the inside function. So as a result, we have a times k e to the kx, which you can see is very similar to y. The only difference between this and y is the k. So actually it's equal to ky. Hey, what do you know? That's exactly what they asked us to show. Okay. Now, show me that the third derivative of y is equal to k cubed y. Oh, that's interesting. Well, to do that, we're going to have to take the second derivative first. So first we'll take the second derivative. And the second derivative of the function is we're going to take this and we're going to take the second derivative. So it's going to be a times k. The derivative of e to the k and a times k remains that way because they represent constant numbers. And then the derivative of e to the kx is simply e to the kx. And the derivative of the inside function, which is kx, is just going to be k. So we're going to put ak squared e to the kx. And then if we rewrite this as a function of y, then we're going to write a e to the kx times k squared. So that is equal to k squared times a e to the kx is simply y. Okay? So the second derivative of y is equal to k squared y. Well, we can kind of see that we're going to get there, right? So the third derivative of y, and I'm not sure if what I just wrote is real notation, so I'm not going to write it that way. I'm going to write f3 of x is equal to, and so now I'm going to say, okay, k squared a e to the x, and then I have to take the chain rule again, multiply times k, and then what do you know? K cubed a e to the kx. And a e to the kx is y, so now we have k cubed y. Okay. Find x when f dash dash x equals 0 for blah blah blah. Okay, so